Hey everyone, how are we doing? The music just stops right there and we're into office hours. If you have questions, let me know. We've got assignments going right now. We got 201. So let's see here. What does 201 have coming up? We're going to do a weekend review for 201 on Mondays, but we can always do 201 at any time. So if you're here from 201, feel free to say, hey, 201's already doing the flashcards. A big thing for 201 is going to be the My Pearson work. I'm going to send out some reminders. I might send out a reminder right now because... Oh, this is the mini term. I was like, what? I was like, why are all the assignments past due? I'm gonna drink a little coffee right here and wake up. There we go. There we go. Their first homework is due by Friday. I'll send out a reminder to them right now and say My Pearson. Let's give them a My Pearson reminder. And let's do this. Let's grab this link right here. Go get this. So if you are joining in, feel free to say, hey, Mewbot needs to wake up. Wake up, Mewbot. Let's go here and say My Pearson reminder. The first homework and quiz are due for My Pearson this Friday. Oh, Mewbot's awake this Friday. Make sure to connect My Pearson to Canvas and start working on them soon. If you have questions, let me know. And then we've got the link right here, so we'll send this out. Might also send, there we go, links to external site. Might send a reminder to 320 and say, just a quick reminder, you have an activity due tonight. Preston, could you tell me if these lines are horribly wrong for activity 1? No, that looks correct right there. Preston, let's hop in. Let's do some work right here. Make sure this link works for 201. Yep, you're hearing some music in the background. Good stuff right there. Hello. How would you recommend tackling 4i on assignment 1? Awesome. We'll do Preston's and then, actually, I think you've got it right there. ABS, the log of x. I think you're missing a tiny bit on it. Let's go take a look at Preston's and then we'll take a look at Rose's. Thank you both for being here. I think, let me get Preston's question pulled up. Preston, I think it wants the natural log of it, right? So let me go get that question. Leave this. I think I sent that announcement. Let's hope I did. Did I? I'm a double checker. So I think it wants the log 10 of the absolute value of the natural log, which you're really close to. Coffee. Yep, I sent that to that class. Let's go here to 320. It keeps confusing me because I have a mini term 201 that I keep seeing for. And let's go here to assignments. Assignments. I think it should be under syllabus too. We should see the upcoming activity. Oh, we don't right there? Let's go to activity. And let's go look at this and we'll look at Rose. Logs are so foreign language to me. I like that right there. Okay, let's take a look at this. You ready? Here we go. So it wants the log 10 of the ln of x. So the log 10, let's just break it down. Let's bring this over here to R. And x is saved as 1/2. So you did that correctly. X is saved as 1/2. Excellent. X is 1/2 right there. We have officially made that to 1/2. Good practice right there. And then let's break down the rest of the code right here with the following. We want the log 10 of the ln of x. So ln is natural log. That's log base e. Now, whenever you do logs, this is the way a log is read. So if you have log of, let's just do log base 10 of 1000. The way this is read is, what do you raise 10 to get 1000? Does that make sense right there? So how would you answer that question? Like, what do you raise 10 to get 1000? So it's always, what do you raise? It's weird how you got to read them. Like, what do you raise 10 to get 1000? And that's the answer to the question. So what power would you have to raise to get 1000? So I think 10 times 10 is 100. Would you raise it to 10? You wouldn't raise it to 10 because think what you're saying is basically the answer is this 10x equals 1000. What is x equal to? Now you're solving for x. This is kind of another way. You're on the right track here, Preston. 20 points. Don't worry, this is just kind of learning how to deal with logs a little bit. We do use them a lot of times in just mathematics and statistics. So what would 10 be to the second? You're close, you're close now. You're very close. What would 10 be to the second? Like, what is 10 squared? So you're super close now. You're on the right track. It'd be 100. So what is log 10 of 1,000? Log 10 of 1,000 is what it's basically you're asking the question down below here. It's going to be 3. X is equal to 3. Not that this is equal to 3. It's that x is equal to 3. And the answer to this is 3. So it's like, what power do you raise 10 to get 1,000? So if we change the numbers right here, and we do the following, and we do, so we can put our cheat sheet down here, down below in a second. What if I ask you the following question? Log base 4 of 16. So log base 4 of 16, what is log base 4 of 16? Take a moment, try to think through and just be like, okay, how does this work? It's asking the question right here. So that kind of puts it in another language right there. So what would log base 4 of 16 be? Log base 4 of 16 would be what? It's just really solving for x right there. And then we'll talk about what like natural log means for half a second. So log base 4 of 16 is saying, now you're correct. Great job, Preston. Excellent work. Let's throw some more 20 points. Thank you, Preston. This is like the mathematics that we just don't use that much. It's all this log stuff. It's like, what the heck's going on with logs? It's just talking about powers and stuff like that. The weird one is the natural log. So the natural log is base E. So when you do natural log, you're actually doing it to the 2.718. I can't write. But natural log is E. So the 2.71828182818 is just natural log. So this is oftentimes just called the natural log. No, we don't have a natural log function. The log itself will take the natural log. We don't have this ln function, which is natural log, at least in mathematics. So log base E, and if you did this right here, would be the question, we'll do that, of the question of what do you raise E to get 2.71828? What power would you have to raise E to? And the answer is that is E, at least carried out a little decimally. This is E, so what would be the answer to the natural log of E for the value of E? So the question is, what power do we raise E to get E? And you raise it to the first power. Does that make sense, Preston, right here to see like with natural log? I hope this has helped your understanding of logs and natural logs a little bit better. Natural logs just have the base of E. It's saying we're using E as the base to say what power would we have to raise E to get the following number. And you'd have to raise E to the first power right here. So hopefully a little better understanding. We're not here to really teach mathematics. We're just here to like learn how to code. And so there's the code right there. And so we have ln of x. So that's going to be log. You might say, wait a minute, why is it log? The reason is, and actually it showed it right there. I shouldn't have went too quick. When you do log, it actually uses E. exp is E. So, and you can confirm this down here by going exp1. exp1 is E. So it's doing base E. And if you're really worried about this, you could go right here and go log x base E. I think that'll use the base. It's the default argument, so we don't have to call it. But this is the same thing as taking the log of x. So that's the log of x right there. We've got this part complete, or the log base E, which is natural log of x. Now we need to go around it and absolute value it. So we're just going to take this value right here and go ABS, put it inside of there. That's the absolute value of it. Now we just need to do the log 10 of it. And what's interesting is you could do this two separate ways. You could go log 10, which is perfectly fine, or you could go log this base equals 10. Just always seeing two different ways. If you notice right here, this is the first argument. What am I taking the log of? And then the second argument is the base of the log. But there's also the log 10 function. Does this make, and this is the answer right here. Did I put the negative sign in on it? I did, right? I was out of it this morning. Let me go here and look. We're going to cheat. Make sure Brian put in that negative sign. And the answer is, I did remember that negative sign. Yeah, exactly. No, that's the whole thing is like, one of the great things about doing business analytics is we're not meant to be masters of mathematics. Like we can just say like, oh, we want the log, the log 10 of 5,000 something. And, if we're a math person, like 5,000, blah, 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 blah. If we're a math person, we might be like, well, that's going to be between 3 and 4. It's probably going to be closer to 3.4. And maybe I'm right. It's 3.7, but I knew it was between 3 and 4. The reason I knew it was between 3 and 4 is because I know the log 10 of this is going to be 4, and I know the log 10 of this is going to be 3. This number's between it, so it has to be between 3 and 4. My guess was a bit off, but I was still like, it's between 3 and 4. We don't really need that understanding of what it'll be between. We just need to know that there's the log 10 of it, because that's what we're going to do. We're going to just solve it. We care more about here's the answer than the logic that would go into knowing why it is this. Not that the logic is bad, but we just should know how to code it. And then when we ask a question, Rose's question was 4i on assignment 1. Let's go over to 4i. Assignment 1, working with data. And we're over here. I want to point something out. I noticed this yesterday. You've got right here the ability to preview it. And thank you, Trace asked a question too. Nice job. Here, Trace, we'll do that question next. We'll do Rose's. Let me put a break in the video. When I go through and put the timestamps, this helps me way later. If I do like a 10-second break, just drink some coffee, put on my chill music. This helps me find these portions of the video. So I said you can go back and watch these later, and it can have like a timestamp right here and say what we're working on. So now we've got a good break. Let's go over to Rose's question. 4i. I'll show you something cool. Let's look at a few cool things right here. You ready? Let's go take a look at this. Here we go. So 2 things you may not have known is you can go here to the... Oh, Blake's got a question. I'm a bit behind. I can't figure out how to even do empty cards. Yeah, let's look at that next year, Blake. You got it. We got Trace's and we got Blake's. You got it, Blake. So what you can do is you can click this and it'll give you the preview mode of it. So you got this preview button right here. You've also got this, which is an index on an RMD file. And so you can go right here to question 4. And here we are. Let's talk about 4i and see what it says. So question 4i says, how many alumni values of lifetime gift to UT, that's what that stands for, are multiples of 1,000? Do not include 0. Ooh, this, Rose, you asked a really tough one. Hint, generate a sequence that starts at 1,000 and ends at this, that goes up in increments by this. Okay. This is the big question. We're going to go here to I, and we're going to make a sequence to start. And I've currently clicked this button, which lets you go into preview mode, which is a little bit nicer, I think. So let's go to sequence. Starts at 1,000. That's going to be from 1,000. Ends at this. That's going to be to this. And then goes up in increments of this. It's going to be by this. We just translated this right here into a sequence. Let's just take a little peek at that sequence. Ridiculous. Crazy sequence right there. So with this sequence right here, I'm just going to store it as sequence. So I like to store my objects so I don't have to manipulate a big thing. That's just going to be my sequence right there. And Rose, let's see. We're one step away, I think. Let's go look at the vector. And for those who are working on this question, make sure you have the data frame loaded in. Here's where you load the data frame. You'll see the data frame is now loaded in up here. I'll show you from scratch, just so you can see the data load in. Make sure it's in your working directory. If you run into any problems, please tell me right away. So don't worry if you're behind or you feel like you're behind. We got lots of time right now. With question 4i, you'll notice that we are working with the alumni data set. I'm going to type 3 letters. Autocomplete kicks in. I'm going to pull the $sign right here, and I'm going to go LTG, and we're going to UT. And now here's where the question, we're missing one thing. This is where I think it, yeah, Rose, you're right here. Now you've got your sequence. Now you've got your vector. Rose, I want to phrase it to you this way. How many alumni's values are contained in this? How many are contained in this vector? How many alumni's values are contained in this sequence? How many alumni's lifetime gifts to UT's values are contained in the sequence on the right? So we have this sequence right here. How many of these people's values are contained in this sequence right here? I didn't create it. How many of these people's values right here are contained in this sequence right here? Or you can just kind of tell me, are they contained in that sequence? We won't do the how many yet. But I think you're right there. Like, use my phrasing if you want. How many of these alumni's lifetime gifts to UT's values are contained in the sequence that I've created right here? Or which ones? Or are they contained there? Are they contained in? So think about contained in and think about what we did today in class. So today in class has a huge hint for all the contained in stuff. So when we want to do contained in, are those values on the left contained in the vector on the right? What would we do? Oh, don't worry about that yet. Just do the contained in. You're right there. You're right there. So don't worry about that yet. 20 points for Rose and everyone else. Great work. Just ask, are these things contained over here on the other side? That's all we want to ask yet. So just think about the only question we have right now are these things contained, like, are these values contained in this? Are these values right here contained inside of this? Only thing about that. So I just want you, I think you'll get it. Just listen to the, yeah, you, I don't know, it's like reading Poker Online. It's like, I'm like, I think they're getting it. So are these values here contained over here in this? So what should we put between it? To say, are those values, these alumni values, contained over here in this sequence? Trace, great job right there. Yes, help each other out. Awesome work. Are they contained in? So if we see a true right here, that means that this person's value was, like, this alumni's value of their donation was part of this sequence. Does that make sense, Rose, what I'm seeing right here? Like, let's try to find the lowest one. It doesn't matter which one we find. Here is value 31, 32, 33, 34. That is value 34. So if I go to this position in this vector, and I go to 34, then look at that, 1,000 right there. If I go to position 862, this should be a multiple of 1,000, and it is a multiple of 1,000. Does that make sense? What I've found is I've found the alumni values of Lifetime Gift to UT that are contained in the sequence that we made right here. So anything that returns true. And now you're on the right path. I think, Rose, you actually have it with the which length. So you've actually done it with what we've created right here. And we can just call this like, let's call this X. I call everything X, if you didn't know that. It's the easiest thing to call. It's just an object. So Rose has, and which is a great way of doing it, they've taken which is going to return the positions of the true, and then they've gone here to length to find out how many positions of trues there are. But since we have a vector of trues and falses, we can just sum it up and we get the same answer. Does that make sense here with the two different things we have, Rose? So you're on the right path with which and length, or length and which rather, but you could also just sum up the trues, because which will turn it into the positions, and then you could get the length of how many positions there are to figure out how many trues there are, or you could just take all the trues and falses and just sum them up by doing this right here. So both of those are the same answer. I wouldn't, and be very careful with your output. You don't want to flood the screen like I'm doing. You just don't want to return pages of trues and falses. I'm probably going to send, I need to send out reminder emails, but I said this on the first day of class. You just don't want to, give me 10 pages of true, false. Like if I'm cleaning this up right here, this is cleaned right now. Yeah. If you look at what runs, if I run this, that's what I would get. And that's the answer. So especially if I'm going to turn this into someone, I might put, there are 575, which meet the condition of being contained in the vector, above. There we go. I'd probably write this right here. So that's probably how I would do it right there. Really tough one, really great question to ask. It's a good one. That's tough. Let's head back here. I think we got Trace's question next, and then we got Blake's. Great job, Blake and Trace. Let's do this. Oh, and then Preston had one too. Last question on the way out. Where should I reference for functions I forget? Question mark. Use the question mark, Preston. So always put like a question mark before a function, and it will give you the information on it. Or you can ask me and I can refer you to videos. But anytime you're wondering about something, whether it be like median or whatever, you can always put a question mark in front of it and it'll bring up the help documentation. So really great question right there, Preston. Sorry I missed that one. Awesome. Thank you, everybody. Let's go look at this next question. Here we go. Time to do it. Trace says for 320, question number 3, once you find the maximum value in column 3, is there any way to find the rows? Is this... Oh, this is the... Yep. Activity 1. Let's do this. Okay. So there's a few ways to do this one. Which row has the maximum value in MT-Cars column 3? Now, if you're not a person like we are, and so this also goes to Blake's question. So Blake, tell me if this helps you out. You're looking for the MT-Cars. The MT-Cars exists at all times inside of R. So the empty cars data frame just exists. It is just there. Does that make sense? It's like one of those free installed, like one of those free games that comes with your computer. So when you call empty cars, it just exists. You can also store empty cars into empty cars, and empty cars will appear in your global environment. But empty cars just exists. Just it's there. Even if you don't have it up there, it's there. It's like something you always know. It's like I always know my name's Brian. I hope I always know that, unless I forget it, which I don't. And this is like me putting on a name tag that says my name's Brian. But empty cars should exist, even if it doesn't exist up there. Like if I go to remove empty cars, that'll remove it. I can still call empty cars, and it'll still exist, even though this will save it to the global environment. It's just one of those like free games, like I keep saying, that R always has in the background. That's like, hey, this is just here in case you want to use it. Kind of interesting that it does that. Weird things about R. And so to exactly, that's the weird. No, Blake, I'm throwing you 20 points. Thank you for asking these things. It's just weird, right? It's like, well, how am I using this if it's not up there? And it's like, it's just always there. It's like the Iris data set is always there. I don't know if there's other data sets. These are the only two I know off the top of my head, I think. Is Sunspots here? Yep. Sunspots is here. These are like the base R datas and other things, and we could probably find more by doing this. These are data sets. Those are in best GLM, so we probably have to load those. Where's Sunspots? Wherever Sunspots is at, that's going to be one of the ones that is in base R. These are all the data sets we have access to, and so you can take a look at any one of these if you want. I might have different ones than you because I might have different packages loaded. But these are just like preloaded games. Some of them you have to call with the data function. Some are preloaded in. Feel free to always ask questions. There's little weird, confusing things like, why can I use a data set that's not in the global environment? I don't know. Maybe I should change that. So to Blake's question, we're trying to find the maximum value, I think. What was it? What question did I write? Which row has the maximum value in empty cars column 3? So let's first call empty cars column 3. There we go. And you know what you could do? You could look through here. Is it this one? I think that's it. 472. I don't see something bigger than 472. So 13, 14, 15. So the answer looks to be 15. Well, that's not a great way of solving it, because what if I ask you for a larger vector? I could say here, so I need to load it up. You load a library array class if you don't have this data set. The main point is to understand that just reading through and asking like which person has the highest weight is a lot more difficult when you get this. Imagine me asking you 472, yes, nice job. Imagine me asking you who has the highest weight right here, like which individual has the highest weight, what row are they in? Well, doing the process we did right here of a small vector is going to be a lot more difficult here. So probably let's try to figure out a way to code this. And I think, Trace, you were hitting upon some ways of doing it. Trace has which, and here I'm going to read off Trace's thing as a sentence. So always remember to read this as a sentence, which I think your code works, Trace. You have, we're going to take the empty cars data frame, and we're only going to look at column 3. There we go. And then we're going to find, oh, so you already know the max value right here. So you've already found the max value. So this will work. This will work. You could have also done, let's say you don't know the maximum value. I would say do the following. And so what I've done now is I've slightly recoded what you've done to say which of these values is equal to the maximum value. Does that make sense? Because maybe you don't know the maximum value. You went through here, and, which is quite all right. Don't worry, you got the right answer. What we're working on right now is making sure we get the right answer, and then we can be like, okay, what if we don't know the max value? Well, then instead of just inserting the max value, let's write a code that finds the max value and ask which of the values in this vector is logically equal to the maximum value in the vector. And I lost a parentheses on that. You can go down here and add something if you forget one little part. And so this right here, I broke it down to exactly. You know what? You wanna like screen watch this. Watch this. Which dot max empty cars. And we're doing column 3. There we go. Yep. And that's the same answer right there. So, or you could do what we did here and do the following. But this which dot max tells you the position of the max. So that's kind of a cool little shortcut I wanted to put into this one, especially when showing how to do it, that we can do, which both of these ways are perfectly fine. This is just showing once again that there's multiple ways to do things, which the function which.max exists to find the position of the max, and there's a which.min. Yep. So excellent work there, Trace. Great job figuring that out, especially. And that's the goal, is that you might code it different ways, and we can talk about like, oh, that's really good here, and maybe we could change this. And then the which.max is a neat little function that I didn't know about it for like a year. I need to tell this story more often. Here, let's go over here. Ask more questions if you have them. Rose, Trace, Preston, Blake. It's open questions right now, so throw those questions out. Let's put on the music. Let's do a little story time with Brian. So I miss Dr. Petrie. He's in Knoxville. I'm here in Texas. But Dr. Petrie would come by my office and give me tests every once in a while, because Dr. Petrie back in 2015, 2015 maybe. 2015 said, hey, Brian, do you want to teach 320? I said, yeah. And so I was teaching 320 at the time, but I was teaching it like with Jump. And nothing wrong with Jump, but I mean, coding is a really good skill set. Coding helps expand your mind, even if you won't be coding for the rest of your life. It's logic. How do we find the position of a levels vector? Which one? Is that one of the ones I did, Rose? Or is that one of the homework ones? Tell me which homework question that is, because I think that sounds like a homework question. Take a look at that. So I really hadn't coded that much, and Dr. Petrie told me he was redesigning the courses, and we'd be doing 320 with R. He's like, you need to get good at R. I was like, I got this. So I was like, I'm gonna spend like a few weeks learning how to code. No. It took like a year, and Dr. Petrie told me I was a beginner after 1 year. And it was like 4 years later, he told me I was intermediate. And it was last year, right before the pandemic, they told me I had hit advanced. He would give me tests. He'd come into my office and ask me questions. And he'd be like, how would you code this? I'd be like, oh, sure. By the end, I'm coding a lot faster. But this is not something you're going to learn in a week. It's not something you're going to learn in a month. It's not something you're going to learn in a year, 5 years, 10 years. You're always going to get better. It's like piano or any other instrument you play. There's no one who's mastered piano. There's just people who are better. So don't worry if you don't know something. Just ask. That's the whole point. Just practice. And you'll get better and better and better. And the more you practice, the better you get. No one sits down one night and says, I'm going to learn how to play piano, and then wakes up the next morning and is an amazing pianist. People just practice. And then over time, the progression happens. Could you walk through number one? Yeah, let's do that next right here. We'll do Rose's, and then let's do Blake's question. Yep. And then calling, it looks like make sure to translate those, Blake. We'll check that out next. Tell me the error you're getting and make sure to translate. Start at the very beginning with the lnx. Remember, there is no function lnx. And then the absolute value needs to be done as a function. Let's look at the Rose question and then Blake's question. Here we go. Let's do it. Okay, so Rose's question. Remember, I am looking at this in the preview format, which is super cool. You can see how to look, and you can even like bold things, so you don't got to know all that LaTeX writing. Can you write formulas here? If you can write formulas, my mind would be blown, and I bet you there is a way. Okay, wait. I just have to see this. Maybe you can't really do the LaTeX formula stuff. Okay, maybe not. If you could have, my mind would have just been... So let's go down here. Rose's question is 5B. So the quickest way to get to that is with the indexing right here. Go to 5 and go to B. 5B says, one level is UTK omega psi phi. What positions in the levels vector is this value? So first thing, Rose, I want you to do in the chat is to code the levels vector. I want you to look at the levels vector. Let's go here and listen to... So I'd like you to code the levels vector. So we have the... How many levels does Greek have? We're in the alumni data set, I believe. So add a column called Greek. So we need to do that. Let's go down here to the very start of this. Alumni. And... And we're going to call... And if I call something that does not exist, it'll create to that. And I want to show you this. By calling something that does not exist, it'll append it onto the data frame. So you see right here what's going to happen when I call to a position that does not exist. I think Rosie got it. It now appended onto that. I wish it didn't move. But it appended on to the end of the data frame. So there's now a new column at the end of the data frame, Greek, because I wrote to a position that does not exist. And Rose, that looks to be correct. So what Rose has done is they have taken... we're going here. We're going to do levels, and this should look at all the different levels. So one thing you might notice is the first levels, as we look through just the names of the levels, is the first value is actually a blank. Now, this is not blank like does not exist. This is blank like I asked you an answer and you just give me like nothing in the answer. It's weird because there's a difference between, I'll show it visually. This answer is this, but it's not that. So we have an answer where there's nothing in there, but that's not the same as an answer of nothing. So this is actually a string of nothing. And what's even more confusing is that third one is a string of a blank. So that's a blank string, a string with a blank. So yeah, just be very careful. It's weird that this first element of this vector of things that exist in here is a name of a fraternity sorority that has nothing in it. But as in, it's not missing, it has nothing in it. So terminology. But this is the way data goes. This is the way data do. And so we want to know here how many people went Greek in the data frame. In other words, how many people do not have a missing value? That's, oh, I was looking at B for a second. How many people in, oh, Rose wants 5B, yeah. One level is UTK Omega Phi Psi. What position in the levels vector is this value? Okay, so let's just copy paste this. Rose, we were so close because now all we need to do is find out, like, let's do a logical check right now to see if someone is Omega Psi Phi. How would we do this? You can just put the start of it. Like, I kind of just, if you just want to put a little bit right here, you can just tell me what to put between these. Because I want to see what level is this in the levels vector? Like, where is this? Like, what level in the levels vector is equal to this? So if I want to go to the levels vector and say, okay, we've got the levels vector right here. I can actually go find Omega Psi Phi, UTK Omega Psi Phi. Here it is right here. I can see the answer right there. So there's the answer, but how could I, and remember, do it in little bits, because this is not going to give us the answer. We can see the answer is 40, so we're like, the answer is 40. There it is. There's that answer. So the answer is 40. The position with Omega Psi Phi is position 40. But if I want to do a logical check to find out if a level is equal to that, what should I put right there? So if I want to do a logical check to see if a level is equal to Omega Psi Phi, what should I put between the two of those? Just two little things to do a logical equals. I just always think, which of these levels is logically equal to this? Who knows? Yep. There you go. And now if you notice, this returns trues and falses, and look where this true is at. So I think you know what to wrap this around next, Rose, because now we can see where the true is. And if you count backwards here, this is position 41, this is position 40. And if you remember from previously when we kind of scanned for the answer, we saw that position 40 is the answer. But there is only one true here. And to find out the position of the true, what code should I put around this now? What code should go around this code? Just type the start of it. Don't worry about typing the whole thing. But I'm going to just wrap this up in some code right here. And when I wrap this up in code, what am I going to wrap it up in? Because now I'm going to take all the vectors of trues and falses, and I'm just going to find out which of these is true by returning the position of the true. So remember, this is a logical vector. And then I can put it inside of something to say which position is the true located in, or multiple trues if there's multiple trues. Like, where are the positions of the trues, or like, which ones are true? So I think Rose is going to type it here. Just running a tiny bit of delay. I might just type it. There we go. And I know Rose is following along. Excellent work, Rose. Does that make more sense to see this right here as we go through it step by step with building? Great job, Rose, right there. Some 20 points. Does it make sense to see this? It's all about building it step by step, being like, okay, I want to look at the levels vector. I want to find which one's equal to this. I want to find out then which position it is. Nice job, Chanel, right there. So it's Chanel, right? Chanel. Sorry, I'm getting everyone's name wrong. It's one of the people in not BTS. Oh my God, Blackpink. I think her name is Rose. Or is it Rose? Maybe it's Rose. My fiance I'll call her like Rose or Rose or something like that because we talk about Blackpink every day. Blackpink's in our neighborhood, so I mean, what you gonna do? But yeah, but all that good stuff right there. I just get everyone's name wrong. It's when I overthink about it, my brain just goes crazy. And then I think it was Blake had a question. Let's hop back here to Space, and we've got free questions after Blake's. Chanel, no worries. Thank you so much, Chanel. I really like it when people give me a phonetic pronunciation of their name. Chanel. Got it. You're welcome, Rose. Great job. I've got a million nicknames too. I had more. No one calls me any of my nicknames now. Beast was one of my nicknames. That was my nickname in high school, is Beast. They'd call me the Beast. They'd be like, the Beast is here. I don't know. Cross country, wrestling, swimming. What else? Track. All those good sports. Probably my main one was cross country. I was like 155 pounds back then. How was that the Beast? I don't know, man. Let's do the next question here. Okay, the next question is about the activity. So when we're looking at building function, that's sick. which thing right there? Which thing is sick? Which one? Which thing are you referring to, Blake? Be more specific, Blake. My tennis coach didn't learn my name on varsity for 7 years and called me Grace. Oh man, yeah. They call me Beast because like they would talk about going beast mode. No, is it Marshawn Lynch has beast mode? No joke. I could find you people from my cross country team who would straight up be like, yeah, we used to like Brian Stevens would be finishing like a race and be like, go beast mode. Like it was Rashawn Oberoi who yelled out like go beast mode, and I like ran like a 502 mile for like the first time. He was like, go beast mode. Like, oh man. I wonder how I don't know. I ran cross country with people when I was on like the cross country clique. Like they're all nice. It wasn't like they were like, you're not part of our clique, but I just didn't hang out with the cross country guys after we'd run races. I'd just run a race and be like, okay, I'm done. I'm going home. But they were all nice. They were like Wes Turner, I knew the best. So, and Saurav Chaudhary. And I don't know. Hope Saurav's doing well and everyone. Maybe one of these days I'll look him up. I don't know. I've talked to Wes. Wes was like, I knew Wes outside of it. What you doing over here, R? Something about these parentheses is mad about. Let's find out. Okay. Let's do this question here. Blake says, and then we'll do Trace's question. So we have right here the number one, x is defined as 1/2. So we need to define x as 1/2. Oh, might be mad about this. There we go. Let's see. Oh, that fixed it. So x is defined as 1/2. Even when I just do this, I like to throw things in parentheses just to make sure it's doing what it's going to do. I say you do what you're going to do. You just, in your parentheses, you do your own thing right there. So now here's my error. It says, So what, good question right here. Who can help us out? What are these inside of, so let's say, what are those? What are those right there inside of R? Be very careful. What are those? What are those right there? Be very careful. That's not being seen as an absolute value. And I'll give you a hint. It's not being seen as absolute values. Is R still doing weird things? I've done something weird. We saw this today. Oh, it's mad about this. Yeah. It's evaluating this as its own thing. So we got to watch out. It's an OR. That's an OR. So even though like, yeah, that is used for absolute value, how are we going to take the absolute value of something? So Blake, Trace, anyone, don't worry, it's just practice right here. How would we take the absolute value of something? Great job, Chanel, right there. So Chanel, put in my head. How would we take the absolute value of something? What's up, Jonathan? Short hair Brian's here. Long hair Brian. I could do something when I come back. Good to see you here, Jonathan. How would we take the absolute value of something? ABS, exactly. ABS is going to give absolute value, which this has already been absolute value, but we also want to natural log it. So that is going to be the natural log of it. So we've now taken the natural log of it, which you notice is the inner portion right here, and then we absolute valued it, and now we can go here and log 10 it, and that should do it. Does that make sense right there, Blake? Yeah, so the which I kind of like, it's meant to be a little trick right there to be like, hey, here's an equation. You can't just drop it right in. You have to then translate it into how the program is going to work with it. But great stuff right there. And then Trace has the next one, generate the sequence going up. Are we using the length? I don't think we are using length though. Let's go ahead and we'll put a break in the video right here. Thank you, Blake and Trace and everyone for just working on this and asking these questions. I want you to work on them. I want you to get stuck and then ask questions. The earlier you work on it, the earlier you ask the questions, the more availability for help there is. I mean, I always try to help out if it's like, I don't know, 11 p.m. at night, I'm going to try to help. I might be asleep or something, you never know. But, the earlier you work on it, the more questions you can ask. I think it just makes your life easier. It's just like a lot of help right there. Jonathan's like, this is not Brian. This is Imposter Brian. Well, get ready. You ready for this? Watch this. Hey, everyone. Welcome to Stat to One. How are you doing this morning right here? How's everyone doing? Everyone doing all right? I think I got something in my hair. Just one second real quick here, everyone. Oh, man. Instant haircut. Look at that. Instant haircut. Just magic. Magic for you, Jonathan, right there. Let's get serious here. Put on our serious face. You ready? Question number 3. Sequence from 5 to 20. 5 to 30 or something like that. 5 to 30. Let's hop back over here to the main screen. And let's do this. Trace like that. I've got other ones that I got to use. We did a bunch of filming. I'm glad you guys like that. I did that for like mother class. They were like, whatever. Main term was like, they were nice. Main term was cool. I'm waiting for the reviews to come in. I'm always worried when I get reviews. I'm just like, one of these days a class is going to hate me. They're going to turn on me and be like, yeah, this YouTube thing, you're not funny, Brian. That's all right. Maybe they'll learn. Maybe they'll have the best grades ever, but they'll think I'm the worst teacher ever. That'd be okay. I'd feel sad, though. Generate a sequence that starts at 5 and goes to 20 and goes up in increments of 3. So generate a sequence that starts at 5, goes to 20, and goes up in increments of 3. So with this right here, Blake was asking, are we using length? So what do you think we should use? It says starts at, so that's going to be from, you know what we could do? We could bold this. Oh, look at that. Go to 2, and then goes up. We can change this word right here. If only we just told you all the words. So now I think this should be a little more clear right here. You have to be careful, though. We'll just take this. We can comment it out down here. So there's the same thing. A little down here, we'll make it bigger so we can see. I'm using Control-Shift+ to increase font. You can always go here to view and increase your font, but I know the quick keys. All the keyboard shortcuts. I don't. So if you do a sequence from 5 to 20 by 3, you'll get the following. If you change this to length, you'll only get 3 numbers. So you'll get the middle number of it. 5, 12.5, 20. Oh, got it right there. So it'll divide it up into even parts. This is not the answer to it. One thing Dr. Petrie always reinforces is naming your arguments, just so, like, if you ever come back. So from equals 5, 2 equals 20, and by equals 3. By naming the arguments, you can also, I like the chill music. It's nice and relaxing. By naming your arguments, you can also mix the order of them. So if you were to rearrange your order right here, you can call things in different orders by naming the arguments. So you can see I can say I want to do a sequence by 3 that goes to 20 and starts from 5. And it's the same right there. Awesome, Blake. Great work. Great work, man. You got this. Bro fist. So, PewDiePie. But you can name the arguments. You can do all this stuff right here. Just makes it easier. But this works the same. The default for this, which arguments have default orders, which you can always check by doing the question mark. As you can see, the default for sequence over here in the bottom corner. Make it a little clearer for you can see. The default for sequence is going to be from, to, and by. Usually it goes by 1. It's got a weird way of doing it. It just usually goes by 1. And then there's the length dot out, which interestingly enough, it does a partial match on this. So this is the argument length dot out. And you can actually just call L because it'll match on that. And so I need to read more up on the documentation of partial matches. It just looks for your argument. I wonder if we do from as like fro. Yeah, it does partial match on that. I would not suggest writing from like that, though. It's not too hard to do that. But you could technically do... We should be able to do the following. It should work. Yeah, I would not suggest that, though. That it's not really that legible for people to read. But those just that just shows that partial matching works with this. So little interesting things we learn as we code more and more, that you can do partial matches, but I wouldn't do that. I'd call the actual name of the argument. You might say, well, why don't you do it for length out? Okay. It's called length out. As you can see from behind me right here, you can see the argument name is length out right here. And it's set to null, which means there does not exist a value by default. Here's the from, here's the to. And so if we do sequence, it should just give us 1. Yep, that's what it gives, because it's going from 1 to 1. And then the by is a formula, which I think finds the, it's doing all that fun stuff. So it's doing the distance from the to and the from, dividing by length out minus 1. So I think it's just doing, I swear it just always solves for 1. Isn't length out null? I don't know. I've always been confused on how the by just, every time I use it without a default value, when I use the default value, it just always goes up by 1. So there you go right there. There's it going up by 1. What additional questions are there? Great work, everybody, so far. How are people feeling about coding right now? What thoughts are there? I hope people are starting to feel a little more, better. It's like, okay, I'm getting the hang of this. You know, when I hit an error, sometimes I'm able to figure it out. I have resources, especially if you message me, if you ask questions in class, hopefully there's a lot of resources. That's my goal with just what we do. There's lots of resources. Feeling good, Trace? That's awesome, Trace, and great work. Class is really interactive. Just don't lose this energy. I know it's summer. By the time we get to the end, have a great day. Awesome, Trace. 100 on the activity, so I'm feeling better. Great job, Chanel, right there. Great job. Excellent, Marine. Thank you for telling me how to pronounce. I'm feeling A-okay right there. We'll keep going. We'll see what more questions there are. Chanel's got 100% on the activity. So 100% on the activity. There's already some assignment questions from the assignment in yesterday and today's video, some of the tougher questions. We'll be doing subsetting tomorrow. So if you're down to the last part, which has you do some subsetting, we'll be seeing that tomorrow. We can always do it now, whatever people want. So if you have questions, let me know. But people are doing excellent. Really, it just comes down to practice. It's just something you can't cram for. You can't learn how to code in a night. Can't learn how to play piano in a night. I got the piano over there. Play piano on stream again, maybe. What other questions are there? Let me see here. You know what we could do? Let's talk a little bit about functions. Let's see if anyone has a question. We'll talk about functions for a second here. Let me clear the screen a little bit. Because we got a little... I don't like ending office hours early either. We got 10 more minutes. We just talk about some stuff, y'all. Let's go over here and talk about some functions. Let's do this. So in 474, we will build functions. Is it not NA? Great question right here. Let's do Rose's question instead. Is not NA, is dot NA of X appropriate for 5C? Let's go take a look at that 5C. Someone's watching this right now in the future and being like, thank you. So we got right here. Oh, is it 5C? Wait, is it 5C? Oh, wait, how many people went Greek? Oh, wait, okay, wait. Oh, I put this in 5C. Ooh, please. We'll label this. Alumni not found because I cleared it out. You can run all chunks above. I did 5B and then I put it in the spot for 5C. So watch out. Okay. So that's position 40. So 5C says, and I don't think that'll work, Rose. So is.NA is a logical check, which tells us if things are NA. And you're asking which things are not NA. So here's the interesting thing about the Greek vector. Let's go look at the Greek vector right here. So we can go alumni, and we've already saved it as Greek. Make sure you've run this code right here to save it as Greek. And make sure it's in the right order, because if you have it down below, it won't knit properly. Please try knitting your assignment too. And what I mean by that is go up here to knit to HTML. You might want to do this every so often to make sure your assignment knits, and mine knits. So, oh, what do I have right here? Oh, I put like a sequence thing. Oh, maybe I think I ran question mark sequence. So mine knits, I have a question mark sequence in there somewhere, but mine knits. And you won't be turning in HTML, but just make sure yours knits, because you might have a code that just breaks it, but mine currently knits and it doesn't look like I have excessive output anywhere. We're good to go. So with that in mind, always check to make sure your assignment knits. You can just do a quick check once again by going here, knit to HTML, just a quick knit, make sure it works, make sure you do not have excessive output. And when you look down here, mine does not look to have just pages of nonsense, and we are good to go. So with that, let's take a look at how to solve this one. I think you're really close, Rose. Oh, Dario, what's up? Yep, short hair. Short hair again for now. Just got to wait some time. Grow back out. Good to see you, Dario. I hope you're doing well. But yeah, short hair for the time being. I know, it got so long, and then I was like, I can't. Oh, and we just had a blink on the YouTube, which YouTube's been very good lately. We just reconnected, disconnected. So sorry if anyone just saw. If I'm not in HD, make sure you click the HD button. How many people went Greek? Okay, so right here, there's some very long ways of doing this one, which I would not suggest. So the Greek vector, if you look at this, we can see individuals and if they went Greek or not. Now, here's where it gets confusing. And this is something you were pointing out. This right here, and there's probably some other ways to solve this that I'm not going to do, which we could confirm. These are the people who did not go Greek, as in they don't have a value. But here's the big question, Rose. What is the name of this level? And we can kind of look back at that. We have the code right here for it. Let's go look at the name of that level. Can you tell me what the name of this level is? Which is very hard to tell from this. Like, I doubt many people can tell me what the name of the level is from just looking at this. But let's go look at the name of that level right here. And be careful, you don't want to include all of this in your output. This, I don't know if I'd include this. You definitely want to be careful. This will create excessive output, so clean up your document. So now what is the name of that level? It's a little clearer to see this right here. So does that make sense that when you see this in the table up here, it's blank because they're not showing you the quotes, but it's a quote nothing. Does that make sense? Like this level right here is this. Does that make sense? Yep, exactly. It's the blank quote. So it's quote. This is what the name of it is. What's inside the quotes is the name of the level, and there's just like nothing inside of it. And so what we want to do here is, you know what we could do? This is a pretty quick way of doing it that I didn't think of before. I think that removed out the first one. Oh my gosh. Well, I'll be. There you go. So that removed it out of that summary right there. We just removed it out. But let's try another way right here. Let's go to alumni. Let's go to alumni $Greek. And let's do not equal to this. So does this make sense? Well, let's put this here first. These are all the people who have the blank, which means they're not in Greek life. These are all the people who are not in Greek life. I know that's weird to say, but this means they're not in Greek life. This means they are not in Greek life. I know it's like a double negative, but there's so many levels of people who are in Greek life that I don't want to do, are they equal to the values of Greek life? I want to do, are they not in Greek life? I want they're not in Greek life. Does that make sense? Why we have not in Greek life, not in Greek life, which means they are in Greek life. It's the double negative here. So what do I just do to this vector now to find out how many people meet the condition of not in Greek life, which means they are in Greek life? And that is what we're trying to find right now, right? How many people went Greek? Exactly. So we are trying to find how many people went Greek. I just want to make sure I didn't reverse it. So how are we going to then find out how many of these individuals meet the condition? And there's two ways of doing this. There's like the longer way with the which length. You could do it that way. I don't think in the world if you do it that way, but I would probably do it the quicker way with the 3-letter word and just be like, boom, got it. This is the way I'd originally solve it right here. 3-letter word, since we have trues and falses, remember these are 1s and 0s right here. Just so you can see it, you don't have to do this. But trues and falses, really? What's it mad about? What are you mad about, R? There you go. Just so you can see, these are 1s and 0s. So these trues and falses right here are treated as R as 1s and 0s. You can literally see the switching. See, that's how R sees them. Trues and falses, They're just ones and zeros. So what could we do to ones and zeros to just figure out, well, how many trues are there? Because that's how R sees trues and falses in the background. It treats this as ones and zeros. Sum. Exactly. Great job right there, Rose and Chanel. Excellent work. Just go here to sum. And the longer way of doing it, so we already did it this way. So that was one way with the sum of the summary minus the first entry of the summary. So remember, in our summary, we had all the entries, and the first entry of the summary was the blank. So you could just go to your summary, because this is the first entry right here, and you could say, I want the summary without the first entry. So now we have the summary without the first entry, and so now we don't have the blank column, and then we could just get the sum of all those values. We could also do a logical check to see if something is not equal to the quote, which we don't want. And then we could just, we don't need the as.integer. That just means showing us that they're equal to trues and falses, are equal to ones and zeros. We can sum this up. The longer way would be to go here, which it's not like a bad way, but do which will turn these into the positions of the true. So these are the people in Greek life. And now we're just going to surround this by a length right here, which tells us how long the vector is. So just knowing a few ways to solve it is pretty good. We could find the percent of people who went Greek really easily, just going here to mean, and that's the percent of people who went Greek. Really? I guess that makes sense. Well, this must be a lot then. I mean, it's the complement of it. Yeah. So don't have all this code. I want to point out why. If you knit this and you see the following, you've probably got an error. Yeah, this is, oh my gosh, do not turn this in. Please do not. And I'm purposely, I want to state why I do this. Yeah, you're going to lose points right here. You're going to lose some major. I might not even grade the full assignment. I might just tell you excessive output cannot grade. The reason I do this is I don't, like, when I want you to watch office hours, I want you to, like, follow along, I want you to practice. I want you to, like, try the code out for yourself. I don't want you to just come here to the video and just copy everything down. Does that make sense? So that's why you'll often see me doing more things. So if you're watching this right now, especially live, I just don't, my goal is someone doesn't fast forward to the end of this and just goes, oh, here's all the answers. And then they have no idea what any of this means. So there's obviously the answer in here, and we've gone over how to get the answer. I mean, just to kind of be pretty clear on what the answer is and the code you need. There we go. But watch out when you're knitting this. So just some advice, especially office hours. The wrong way to use office hours would be to just, like, fast forward to the end of each problem and be like, here's the things I need to write down. And then the right way to use office hours are, like, understanding the code, going through the steps, and I try to be as clear and concise as possible while having a little bit of fun. So hopefully it's making more sense, and the goal is practice, because copying down code doesn't help, but, like, following through and being like, okay, what do we do next? Where do we go from here? What does this code mean? What's the logical check doing? What's removing the position doing? And whenever you have questions, let me know. That's got it. We'll hop back here to space. Does anyone have any final questions? Even if it's near the end of office hours, feel free to ask. We're back here in space right now. We'll see if there's any last questions right here. Especially as the semester gets going a little bit more, I'll probably go for, I mean, office hours just last kind of as long as people have questions, or if I'm going to pass out or something. I don't know. You said we'll cover subset and sorting tomorrow, and if so, if we're a little confused on question 7, it's okay. Totally okay, Rose. Do you want, let's do one of those now. I totally mean, don't worry about, like, being like, hey, office hours almost over. So here, I'll talk about subsetting here just a little bit to get everyone. Oh, yeah. Let's do this one. This one's tricky. Let's hop over to it. Okay. So this one's pretty tricky. We are on question 7 down here at the bottom. So the first thing we need to do is create a subset called sub. We're going to store into that. Who graduated between the years of this and this, including those years, and who have donated to UT, those who do not have values of LT who are greater than 0, and 3 whose majors are either statistics, finance, and accounting. So let's do the subset. Now, the way subsetting works, and it prints dimensions, cool. The way subsetting works, we'll just run subset first. And zoom in. Subsetting works with the following commands. The first thing you put in subset is what you are subsetting. Then you put a comma and you're in the conditions. I'm going to put that on a separate line right here. Then there's another argument here, select, which if we're going to select certain rows. Does it say to select certain rows? Keep only the columns. That's the select argument. So this here is the select argument. Select argument. And here is what we are subsetting. Well, we need to know what we're subsetting. Here's the conditions. And there's conditions. Okay. So what are we subsetting? We are subsetting the alumni data frame. Now, the hard part a lot of times is going to be the conditions, because a lot of people might start putting commas. Don't put a comma, you'll leave conditions. You know, we're in the conditions right now, but if you put another comma, you leave the conditions part of the function. So the first thing we're going to do, let's just do this. Little bits. Code works, prints out the full alumni data frame because we're not even subsetting right now. So at this point, we're just printing out all of the alumni data frame. It's printing out just a few rows and stuff. But now let's go and create a condition right here. One of the questions says we need to go to, the first thing is degree grad year. It needs to be between 92 and 98. So I'm going to say degree grad year is greater than or equal to 1992. I got to double check. So if I make an error here, there we go. And so we run this and it works. I could check it to make sure, but I think we're good. And then, so here's where our ands come in. Degree grad year. Now, I want you to notice how it indents this. It's indenting further in to say I'm still in the same condition. And then we go to, and I might, you know what? I'm going to leave this right here. I think you can maybe, I'm going to let's see if people figure out the rest. The last condition is a little tricky, but you'd put some more conditions right here. Does that make sense, Rose? From here, I'm just doing a condition, subset this data frame, and then do this condition, and then do, well, subset this data frame with the conditions this and the condition this, and we can do some ors or something. But when I put the comma here, I leave the conditions. You'll notice it goes back to the first indent, and then I can go right here and say select. And select is only going to select certain columns right here. So I'm going to copy these. Don't ever try to write things yourself. Just copy them. And then we almost have everything, but these need to be in quotes. And so we can see how we're doing. We won't have the right dimensions on it right now, but those are, we're only going to select those, and we're going to call it sub. And then we can check out the dimensions of it. And that just gives you the rows and columns. So we at least have the right sort of columns right here. We've selected columns 1, 2, 3, and 4. We can also take a look at this here to see that we've selected these. We don't have the right majors yet. That's going to be the tricky one to code. It's not too crazy. The donation one is probably the easier one. You're just going to look at LTG greater than 0. I think it's because we're just trying to find people who donated. And then the majors one will be a percent in percent. Like, is somebody's major contained in? Also notice that since I'm inside of this subset, I don't call alumni anymore. I'm just calling the vectors inside because it already knows I'm subsetting inside of this. So I don't have to say alumni $ degree grad year 1. I just call this right here. Is that making more sense, Rose, to see how this works? The first thing is what are you subsetting? Then the second thing through the comma right here, the second argument is what are my conditions? And then the third argument right here is what columns are we selecting to output for the subset? So what data frame am I subsetting? What conditions am I subsetting on? So I could put another condition here really easily. Why not one more? I'll do the easy one. I'll leave the hard one. We could do it tomorrow. We could do the hard one tomorrow. You're welcome. The donation, what is it called? LTGUT, right? So if we want to do LTGUT greater than 0, and now we've subsetted further, and you can see the dimensionality has gone down, or the rows have gone down. So we have found fewer because we're subsetting on only the people who've donated. So we just need to do another and right here. So we go and by doing another and, wherever and is at. How do I lose and? I can never find it on this computer. By doing another and, you'll notice we're in this sub indent right here. And I like doing you don't have to do indentions, but it makes life so much easier to read the code. So I'll let you think about that last condition right there. But I think that's got it. We'll head back here to space. Great questions, Rose. Thank you so much. Well, I think that's got it, everybody. Great office hours, great questions. 2-1, you're always free to swing by. I think we'll start doing some of their homework soon. We'll probably be extending office hours. Just want to get as much work done for as many people and keep taking those questions. So with that, we're done for right now. But keep up the great work. And feel free to ask questions. Swing by any time. I see I got 5 messages on Discord. I'm going to head over to Discord, answer some questions, go eat some lunch. You're welcome, Chanel. You're welcome, Rose. Good seeing you here, Daria. And seeing how else, Trace and Blake. Good to see you. I will see everybody later. Let's throw out some 20 points. And remember, 10,000 points is the goal. So it's end of week 1 almost, and you're doing amazing right there. We're going to make 10,000 points the goal. And the reward tiers get further apart. But you got this. You'll make it. Let's do it. Don't worry if you don't get the 10,000, though, because it's just little smaller rewards as we go on. Rewards get smaller. Points get bigger. Let's do this. Stat 201 next time was my catchphrase. Bye for now. Bye. Bye, Puppet Shark. I forgot my catchphrase.